Alright, so today we are taking our quadratic functions and we are solving them for x. Now when they say solve, they mean we are figuring out what x equals when y is 0. Okay? We are finding where do our parabolas cross the x-axis. Okay? So there is a possibility that it crosses how many times? Twice. That would be 2 real solutions. There is a possibility that it crosses or touches once when the vertex is on the x-axis. That would be 1 real solution. There is also a possibility that it never crosses, right? Like that, or maybe like this, right? That would be no real solutions. Now, there's always going to be solutions. You're always going to be able to solve for x, okay? And we'll get into what I mean when I'm saying real solutions later. But for what we're talking about, there will be no real solutions if they don't cross or touch the x-axis. Okay? There's going to be 3 different ways we're going to do this. One way will be by graphing it. If you graph it, you'll be able to find the x-intercepts. The second way will be solving it algebraically. That only works sometimes. And the third way will be factoring it. Also only works sometimes. However, those last 2 ways are the easiest ways. So if you can do them that way, you are going to want to do them that way, algebraically or factoring. Okay? If you can avoid graphing it, you're going to want to avoid graphing it.
I have a question.
Yes.
You said they sometimes don't work. How do
I'll
you determine?
tell you. Okay. All right. So we're going to start off by graphing. So they give us a function, x squared minus x minus 6 equals 0. So the difference between this and what we have been doing is I don't have a y anymore. Okay. That's because we are trying to find out where it crosses the x-axis. Well, if it's crossing the x-axis, right? If it's crossing the x-axis, what is the value of y? 0. Right? At any of these points here, y is 0, correct? So I plugged 0 in for my y. Okay? So that's why that's 0 and not y anymore. Now, how or what do I have to do? First of all, it's in standard form, correct? Okay, we graphed a whole bunch of these equations back in chapter 1. How do I graph this? It's been a while.
-6 is the y and I'm just kidding, it's 0. Well, negative b over 2a.
Negative b over 2a is going to give me what?
The x of your vertex.
The x value of your vertex. So, b is currently -1, so negative 1 is
1.
positive 1 over 2 times 1, which is
2.
2. That's the x value of my vertex, right? How do I find the y value of my vertex?
Plug x in.
Plug it in. Okay, so I have 1/2, and I'm going to rewrite this all the way out. 1/2 squared minus 1/2 minus 6. Everybody with me so far? I just took my x value, plugged it in. Now I'm going to find my y value. Well, 1/2 squared is 1/4 minus, I'm going to go ahead and change these to denominators of 4. Is everybody with me on that?
Yeah.
Okay, so I would have negative 2 over 4 minus 24 over 4.
He just changed it all to
Negative
the
6 is the same as negative 24 divided by 4, right? Okay. So I have 1 minus 2, which is
Negative 1.
Negative 3.
Negative 1.
negative 1. Negative 1 minus 24 is,
Negative 25.
so my y value is negative 25 over 4, which is like negative 6 and 1/4, right? Okay. So now I should be able to graph my vertex. So I go to positive 1/2 and I go down 6 1/4. Now, this is a scenario where we don't really care what the graph looks like. We just want to figure out where does it cross the x-axis, because we're just trying to solve for x. Okay? So you don't need to pick the closest points, because it is very, very unlikely that when I plug in 1, I'm going to get 0 for y, right? Very, very unlikely that it's this steep. Okay, so I'm going to skip 1. I might even skip 2, because odds are still pretty slim, right?
Yeah.
So I'm going to jump clear over to 3 and see what happens. Well, 3 squared is
9.
9 minus 3 minus 6. Well, 9 minus 3 is
6.
minus 6 is
2.
0. That's actually the first time I've done this problem today. Okay? But just using some of the logic you know, it's probably not going to be super close to that point, right? Unless the vertex is clear up here, right? But if the vertex is this far down here, it's probably not going to be right next to the vertex. So I just skipped over a little bit further and happened to pick the right one on the first try.
That's the only way to do that. You just kind of guess your point.
That's the only way to do it, is to pick an x value and plug it in and see if you get y equal to 0. Okay? So use some logic. If it's clear down at the bottom, odds are you're probably going to have to go further away to find that number, right? Okay, what happens if we would have picked 3 and it would have been up here?
It would have been right.
Then I'd have backtracked and went to 2, right? Okay? Now that I know 3, I also know that there's an axis of symmetry right here, so I can just do what?
Reflect.
1, 2 and a half, 1/2, 1, 2. That's where my other point would have to be. You don't need to draw the parabola. You don't need to pick other points because we don't care about them, right? All the problem said is solve for x. We just had to do it by graphing. So that means that my x values are -2 and +3. Meaning, if I would plug one of those two numbers into my equation and solve it, I would get 0, right? For what?
Yes.
And that's where my graph crosses the x-axis. That is the solution to our parabola. That's what x equals. Okay? That's how we would solve that equation. Okay? So I'm not going to do another one of those because we should be able to graph. And if you can graph, you should be able to pick points until you figure out when y is 0. Okay, we should be able to handle that. I'm going to move on to these other ones because at times they're a little bit more difficult. So we're moving over to example 2, which is going to be solving quadratic equations algebraically. And the first function they want us to solve algebraically is 2x squared plus 14 equals 70. We're going to do 3 of these ones because there's a lot of different scenarios you could come across. Now, the way you're going to know to solve it algebraically is if there is no x to the first power. Okay, that's going to be sign number 1. Everybody see how there's no x to the first power? Mm-hmm. So here, if there's no x to the first power, I can just get x by itself. I can move all this stuff over and square root in the end. And I have x by itself. Okay, so let's do that. Subtract 14. So I have 2x squared equals 56. Divided by 2. X squared equals
23.
28.
Oh.
Oh.
Okay.
Then don't you have to find the square root of that?
Now I have to square root both sides. Okay? Because remember, to get rid of a squared, I square root and those cancel. So I have x equals, now let's go ahead and break this down like we did the other week. That's why they had us doing that and maintaining mathematical proficiency. 4 and what?
7.
4 and 7. So I have the square root of 4 times the square root of 7.
So it would be
Square root of 4
2
is
times the square root of 7.
2 square roots of 7. So I actually have x equals 2 square roots of 7. Now, we are missing something, and this is something that you might not have ever been taught. I'm not for sure. There are supposed to be two answers here. Okay?
Don't you just do like the opposite?
You need a plus or minus right here because
algebra.
when I take the square root of 4, you are asking yourself what times itself equals 4, correct? Well, 2 times 2 equals 4, but negative 2 times negative 2 also equals 4, correct?
Yes.
So the whole time you guys have always just gave positive answers when they ask you what's the square root of 4, but the square root of 4 is actually plus or minus 2. There's 2 ways to get to 4 by squaring a number.
Yeah, we learned it.
You have done
answer
this?
would be plus or minus?
Okay, so your answer is going to be x equals plus or minus 2 square roots of 7. Which hopefully makes sense to you because most of the time your parabola is going to cross the x-axis twice, right? So you're going to need 2 answers. Okay. We good with that? Okay. Now, going on, one that's a little bit different. I have 4x squared plus 20 equals 16. Now, this appears to be a very similar problem, right? Okay. I still do not have an x to the first power, so I can solve this thing algebraically instead of graphing it, so that saves us some time. Start by doing what? Subtract 20, so I have 4x squared equals negative 4. Divide by 4, x squared equals
Negative 1.
negative 1. Square root, I have x equals plus or minus the square root of negative 1. As far as you guys are concerned, that's not possible, right?
Yeah.
Okay, we'll talk here, I believe, in the next section, so Wednesday, that is possible. You just aren't going to get a real solution. Okay, so if this happens right now, your answer is no real solutions. What does that mean?
It means you don't have an x.
Right, it means that parabola never crossed the x-axis, right? So it was one of those scenarios I talked
It's just
about.
inside of a quadrant.
Up here, it's either over here, or it could be here, or here. But I know it's opening up because A was positive. Okay, so I know it's above here. Okay, and it's opening this way, it's just never touching the x-axis. Okay? Alright, so that's the second scenario that you might come across. This next one is going to take a little extra work. Okay, but it's still easier than graphing it. I have 3/4 x plus 1 squared equals 10. Now this one looks a little different because I don't actually, from what I see, I don't have an x squared, right? But I know x plus 1 squared is x plus 1 times x plus 1, which means I could FOIL it, which means technically I have an x squared and an x to the first, right? If you were to FOIL it.
Can you distribute?
Do you have to distribute first, or like
No.
do this?
Exponents first.
No.
Parentheses, exponents, and then multiplication. Okay, so don't distribute first. And actually, you don't ever have to FOIL this. Okay? If you see it, now this would be in vertex form if I took that 10 and moved it to the other side, right? Vertex form.
Yeah.
Okay? If it's in vertex form, solve it algebraically. Okay, so let's go through this. We're trying to get x by itself, right? let's get rid of our 3/4 then. How do I do that? Divide, because you're multiplying, so that's the same as multiplying by 4/3. So I multiply by 4/3 on both sides. So now I'm left with x plus 1 squared equals
10 times 4/3.
Like 30 over
40 over 3.
40 over 3. You should be able to do that in your head.
Hello.
Okay. Now, instead of foiling, can I just get rid of my square?
Yeah.
By doing what? Square rooting. It's okay to square root this whole thing, as long as you do it to this side.
Heyo.
Okay, so those cancel.
Oh, and then you have to do.
Now I have x plus 1 equals, now I know it's plus or minus, correct?
Mm-hmm.
The square root of 40 divided by the square root of 3.
Wait.
Wait, can't you break down 40 then?
Yes, we're going to break down 40 here in a second.
Patience,
Okay.
children.
Now, before I finish bringing that 1 over, which I will do, correct? I'll bring that 1 over. Okay, before I do that, let's go ahead and reduce this. So I have the square root of 40. What can I take out of it?
4 and 10.
A 4 and 10, so I have the square root of 4. Square root of 10, square root of 4 is 2. Can I do anything with the square root of 10?
Nope.
No, it's done. Okay? So now I'm sitting here with this. I have x plus 1 equals plus or minus 2 square roots of 10 over the square root of 3, right? I'm still not going to let you bring that 1 over yet because I do not have that fully simplified on the right side yet. Okay, one rule that I don't know, some people in last class said they learned it, but you can't have a radical in the denominator.
I learned that in chemistry
Yeah, we
this,
learned that in
this
chemistry
morning,
this morning.
first period.
Oh, really?
He told us,
Okay. Did he tell you how to get rid of it?
No.
Okay, well, we're going to get rid of it. We are going to do what's called rationalizing the denominator. Okay, right now, the square root of 3, that's an irrational number. Okay, it cannot be written as a fraction. So, we're going to turn it into a number that is rational. Meaning, I got to get rid of the square root. Okay? To do that, I'm going to multiply the top and the bottom by the exact same number. Because if I do it to the same number on top and bottom, let's say this isn't the number, this isn't the right number, but let's say it's 7 and 7. Isn't that just 1?
Yep.
So I'd be multiplying by 1, but it's going to look a lot different, correct?
Does it
You with me?
matter if we do like 6 over 6?
It's going to matter. I'm going to, okay? Because I need that radical to go away.
Okay.
Okay, so on the top and the bottom, I'm going to multiply by the square root of 3.
Hold on.
Things are about to get saucy.
Okay?
Oh, I thought
I'm still just multiplying by 1, right? Square root of 3 over the square root of 3 is just 1. So I'm still only multiplying by 1, but it's going to change how this whole thing looks.
Wait, do you multiply 10 and 3?
hang on.
So I have x plus 1 equals plus or minus. Now, 2 times 1, because I'm multiplying the outside and the outside, is just 2. The square root of 10 times the square root of 3 is the square root of 30. Okay, now this is what happens on the bottom. What is the square root of 3 times the square root of 3?
1.
It's the square root of 9,
Okay.
which is 3.
I was right.
Okay, that will happen every single time as long as you use the correct radical.
This is legendary.
This is not.
Okay. So now I have rationalized my denominator. I no longer have a square root down there. Now I can bring this 1 over. Now I also want you to be careful. The correct form to write this in is -1 plus or minus 2 square roots of 30 over 3. You want to put that radical on the right side.
Why?
That's just standard form.
But why
Because
don't you-
algebra.
why don't-
Same reason if you wrote a quadratic, you do x squared plus x plus a number. It's standard form, so everybody's doing it the same every single time. We're all on the same page.
Why don't you put -1 behind the quadratic?
Because that's not standard form.
Because algebra.
Because somebody
It applies
decided
more.
they didn't want to do that.
It applies more when we start working with complex numbers, which we will get to. Okay?
I don't want to.
So, now here's the other thing. How many answers are here?
2.
There's 2. If they wanted you to find them as decimals, in your calculator, you'd have to do -1 plus 2 square roots of 30 over 3, and then you do -1 minus 2 square roots of 30 over 3. That gives you 2 different decimal answers. Okay?
You don't have to do that though, right? That's not necessary.
No. Leave it like this.
Good idea, good idea.
Okay? That's solving it algebraically.
So it is graphing, algebra, and what's the other one?
Factoring.
Are we doing that today?
Yep.
Okay.
We're doing it all today, remember?
No.
Okay? Now, could you have solved these algebraic ones that we just did? Could you have solved them by graphing?
Yeah.
Yes.
Probably.
Okay? Graphing's not very much fun though. Okay? I would not like to graph every single problem. I think that would really stink. So I'm not going to. I'm going to solve it the easiest way. If you can solve it algebraically, solve it algebraically. Okay? So now we're flipping over. We're on page 96. Now we're going to solve by factoring. So the problem that they give us is x squared plus 2x equals 48. When we were factoring the other day, did I ever have another number on the other side of the equal sign?
No.
No, it was always y. Actually, I think there might not even been anything, right? There might not even been an equal sign. Okay? I need to get that 48 on the other side so it's in standard form and I can factor it. Okay, so just quickly subtract that over. You can probably do that before you ever write anything down. Okay, so now it's equal to 0. So I'm trying to solve for x when y equals 0. How did I factor something like this?
What can multiply to the second number and add to the first number, right?
Not quite.
No, that's the wrong
Oh, is it the adds to whatever?
I think you're, yeah.
Adds
Multiply
to
the-
Yeah, I remember seeing this.
And
Isn't it?
I don't need to do that.
No.
Change to factoring by grouping, is that what this is?
No.
Okay,
so
so
it's
it's
just regular.
Was I on the
Just
right
regular
track?
factoring. Guys.
Oh.
Was I on the right
Multiply
track? Don't you have to
15
like?
and
Just have a
Is
factor.
it the other way? So is
Well,
it?
I need to see what 2 numbers multiply to
That's what
this.
it is.
No, you said multiply to b.
Oh no.
Uh-huh.
I need multiply to this, add to this.
Let's do
negative.
8 and -6. Now, last class period said -8 and +6. Okay? If that happens, as soon as you find 2 numbers and you set up the factoring, just double check it. Make sure it makes sense. Usually you didn't mess up your multiplication. Okay? 90% of the time you're not going to mess up the multiplication. It's the addition. Does -8 plus +6 equal +2?
No.
No, so then you know that you got these backwards. Double check it. Does 8 plus a -6 equal +2?
Oh, yes.
Yes, we're good. Okay? You still are equal to 0 though.
Hot
Just
dog.
you know any simple ways to find out multiply to C, add to B? Because I'm really bad at it.
Me too.
know your multiples of numbers.
We're on the steps over
That's
there.
yeah, that's it.
Okay. That's it.
That's the easiest way.
That really long one that was on homework.
Yeah, there was a couple that were rough.
I got the 225 one. I was
The
struggling.
Okay.
last one was really long.
Guys, I promise you I go all the way to the bell, so you want to hang with me here.
Okay.
Okay? So, now that I have this, I still have to figure out what my x values are. Okay? There's going to be 2. Now, all you need to do, and you got to make sure you know how to do this because they're not always going to be as easy as this one. And we'll do one next that's not. But you have to take each set of parentheses, x plus 8, set it equal to 0, and x minus 6 and set it equal to 0. Now these ones are going to be easy to solve and you'll probably figure out a pattern there. My answers are x equals negative 8 and x equals positive 6.
Wait, that's just the intercept form.
Right, this is intercept form, right?
Oh.
So your intercepts are negative 8 and positive 6. Same thing, your intercepts are negative 8, positive 6. Okay? It'll always be opposite this sign if this number's just 1. Okay, I'll show you one here in a minute. It's not quite as easy. But you need to understand what you're doing here. You're taking each one of those, setting it equal to 0, and solving. Okay, so your two solutions to this quadratic are negative 8 and positive 6, meaning this is where what's happening? It's where it crosses the x-axis. Okay. The next one is a little bit more difficult. Now, on the next one, they change what they're asking you. They give you a function, f of x equals 4x squared minus 13x plus 3. Okay, the difference is they didn't put 0 in there and say solve for x, right? So there's currently two variables. There's a y and there's an x. What they tell you here for the directions is they ask you to find the zeros of the function. It means the exact same thing. Okay? The only difference is they didn't plug 0 in for you. Okay, so you got to do that. They say find the zeros of the function. You plug in 0. Okay, don't let them confuse you. You're still doing the same thing.
They confused me.
That doesn't take much time. Radiant, do you remember how to factor a problem like this if this is not a 1?
Nope. Yes,
I
wait,
know.
wait.
Yeah, this is the one you're good at.
Actually, I don't got it. Don't.
I got it right here.
Olivia, what's the first step?
Gotta multiply the A and the C.
Multiply A and C.
Yes, because Lainey and I were working on it on Friday.
And that gives me what? In this case, I get 12. So now,
Oh, I know the
I need two numbers that multiply to 12, but add to
13.
13. Negative 13.
negative 13.
It's negative 12 and negative 1.
Negative 12 and negative 1.
Oh, that was bad.
Okay? What am I going to use those numbers to replace? The x's, or negative 13x in this case, right? Okay? So instead of negative 13x, I'm going to fill in negative 1x and negative 12x. And then I'm still going to bring my A and my C down with me.
And you group them together.
And we did that so we could factor by grouping, just like I just heard.
Then
So I group the front two. Now be careful with this. This catches some people. When I do this, I need to know that there's a plus sign here, right? When I include that negative in my parentheses. No, there's a plus sign in between still. Notice I'm carrying down my 0 on the left still. What can I take out of this group?
An x.
An x. 4x squared divided by x is
4.
4x. Negative x divided by x is?
Negative 1.
Just kidding. Negative 1.
Remember, you're dividing. You're not subtracting, you're dividing. Plus, what can I take out of both of these?
4. 3.
3.
And I end up with
Negative 4.
negative 4x
Minus 1.
plus 1.
Plus 1.
What's the problem?
There's a plus and there's a minus.
Cool.
You just get rid of that negative.
There's a negative here and a positive here, and this should be a positive and that should be a negative, right?
Yes.
So instead of factoring out a 3, could I have factored out a negative 3?
No.
Yes. I factor out a negative 3, that's a positive 4x, and that's a negative 1 then.
So now it's negative.
Now am I okay because I have the same thing in parentheses?
Yes.
Yes, now I'm good. So now, the x goes with
X minus 3.
the negative 3, so I have x minus 3 and 4x minus 1.
What?
Okay.
What happened?
You
Oh,
added
side.
the x and the
Yeah, I
negative.
know.
Good.
Yeah, I wrote that.
Does everybody know where I got those from?
Yes.
Yeah, I just forgot.
You just did it.
Got x minus 3, and I got 4x minus 1. Okay. Now, I still have not found my solutions. Hopefully this one's easy for you. That's going to give me x equal to positive 3. This one will. But this one, that one could be a little harder, so I'm going to do 4x minus 1 equals 0. Add 1. 4x equals 1. X equals 1, 4. So my solutions are positive 3 and positive 1, 4.
That one was much harder. That's okay.
I expected that to be harder.
Why don't do the comma that throws me off?
What?
It makes it look like that intersection.
Yeah, it's not an ordered pair though.
Yeah.
Is that what you're saying? Yeah, understand that's not an ordered pair. It's just a list of numbers. Okay, it's just crossing the x-axis
I
twice.
put the and sign so I don't confuse myself.
That's fine.
We're definitely not.
Okay.
We still got 10 minutes or so.
What
Questions?
lesson is this?
Questions on that one?
3.1.
So this whole thing we're just trying to find two x.
This whole thing, we are trying to find where does my graph cross the x-axis. It might cross it twice. Usually it will. Most of your answers are going to have 2 solutions. It might cross it once. It might just be at the vertex. Or it might never cross it. Okay? Right now, it'll never cross it if you get a negative underneath a square root for you guys right now. Yes.
How do you know if it only has one?
If it only had 1, when you got it all factored out, it would look like this. They'd be the same thing.
Oh.
Because no matter what, when I solve this, I'm going to get x equals negative 2, but I'm going to get it twice. Meaning that would be that the vertex would be at negative 2.
Okay.
Is what that would mean. Yes.
So you do graphing when we're gonna do comparison.
You do graphing when you can't factor it or solve it algebraically.
Okay, and you do algebraically when there's no
X to the first.
power.
Yeah. Or if it's in vertex form,
And then you factor when
whenever you can.
just whenever.
Factoring should be the easiest way. Okay?
Well, question.
Yeah.
How do you know if you can factor?
Would be 0 equals.
If I had something that so I'm going to make this up and hopefully it doesn't work. What multiplies to 4 but adds to negative 6?
Nothing.
Nothing. Not factorable. You need to graph it.
Oh. Or if you do, but you can do that one algebraically, right?
No.
There's an X in there.
It's got an x squared and an x. I'm not going to be able to solve it algebraically.
But I thought you could do that.
Well, there is a way, but I haven't showed you how to do it.
Oh.
So
Let's not get more
I
complicated.
thought you did it algebraically because there was no x and b. No.
There is an x in the
But there is though. There's an x right there and a b right here.
So you have to graph it.
Yes.
So
If it looked like
standard
this,
form-
if it looked like this,
Does the positive or
there, yeah. If it's in standard form and you can't factor it, you got to graph it.
Okay. Oh.
Sweet.
Thank you.
And there goes the lights. Oh, we're not done. That's okay. We'll just we'll just keep going.
Someone's on the power lines,
Yeah,
please?
so
I bet some power lines. For
So I bet my video.
It's still good.
But you can't see it.
No. not even a
That'll be
little.
an issue.
Hey, do you want to use a flashlight?
Just open the window.
I thought I heard.
Flashlight.
I thought I heard it kicking back on.
I hate myself.
No, I think there's people.
Oh, I can turn my flashlight.
Okay, so